Good afternoon, class. We are looking at Pre-Calculus Chapter 7, Trigonometric Identities and Equations, Analytic Trigonometry, Section 7.1, Part 1, Trigonometric Equations. Chapter 7, Trigonometric Identities and Equations. We're going to look at trigonometric equations, identities, sum and difference formulas, double angle and half angle formulas, product to sum and sum to product formulas, solving trigonometric equations. The objective for this section: solve equations involving a single trigonometric function, solve trigonometric equations using a calculator, solve trigonometric equations quadratic in form, solve quadratic trigonometric equations using fundamental identities and using a graphing utility. So, reminding everybody of fundamental identities that have been discussed already. Unit circle, x squared plus y squared equals 1. P has coordinates x comma y or cosine comma sine t, and the rest of them follow as we have seen them a number of times. Every trigonometric function is periodic with a period of 2 pi except tangent, the period of pi, and therefore cotangent. Every trigonometric function is an odd function, meaning f of minus x equals minus f of x, except cosine, where f of minus x equals f of x. Cosine of minus x equals cosine x, and therefore secant follows it as well. These are some of the fundamental identities that are extremely important. Pythagorean identities: sine squared and cosine squared add up to 1. Tan squared plus 1 is secant squared. 1 plus cotangent squared is cosecant squared. Quotient identities: tan theta is sine over cosine, cotangent is cosine over sine. And reciprocal identities: cosecant is 1 over sine, secant is 1 over cosine, cotangent is 1 over tangent. And again, reminding you of the odd and even properties we just discussed. Graph of the sine and cosine function where we are dealing with sine x. Between 0 and 2 pi, that is the restriction for one complete cycle, and then we go indefinitely on both sides as far as the sine or cosine is concerned. So we cut it into 4 equal parts, resulting in 4 arcs. And so we write the endpoints. This is 1 arc, 2, 3, 4. Y equals cosine x, same thing from 0 to 2 pi. Cut it into 4 sub-intervals, giving us 1, 2, 3, 4 arcs. Sine is the same as cosine of x minus power 2. So the period is t equals 2 pi, amplitude is 1. If we have a sine omega x, then it, or cosine, it changes the period to 2 pi over omega, amplitude to absolute value of a. As far as the inverse functions are concerned, when it comes to trigonometric functions, none of them has an inverse because they're all periodic and they fail to be a one-to-one function. However, restriction, for example, for sine from minus pi over 2 pi over 2 makes it a one-to-one, and therefore we can come up with the inverse function. And recall that composite function f or f inverse is always equal to x as long as we have the proper domain. In this case, the domain would be the domain for x. So x must be between negative pi over 2 and pi over 2. In this case, the domain must belong to sine inverse. So x must be between negative 1 and 1. The same thing happens with cosine in essence. Everybody remembers that. And tangent. So for cosine, we restricted from 0 to pi. For tangent, from negative pi over 2 to pi over 2. The endpoints are not included. So that's the synopsis of what we covered as far as graph of trigonometric functions and their inverse. Now, this was the reminder so we could get started with this, everybody. And now let's look at a simple example. Determine whether theta equals pi over 4 is a solution of the equation, which means just plug in, see if it works. So let's plug in. Now, sine of pi over 4 is one of those common arcs. We should know it's square root of 2 over 2. These two cancel each other. We get 2 square root of 2. It is not equal to 0. Pi over 4 is not a solution, just as we did in algebra. What about 5 pi over 4? We are going to plug in. Now, 5 pi over 4, bear in mind, the reference arc, it's still pi over 4. So it has the same value, but is it positive or negative? Depends on the quadrant. 5 pi over 4 puts us in this third quadrant where sine is negative. So the same value, but negative. That means square root of 2 over 2, make it negative. And they do add up to 0, which makes 5 pi over 4 a solution of this equation. And again, reminding everyone of various quadrants and the sign for trigonometric functions. 2 sine theta minus 1 equal to 0. We move the negative 1, make it positive 1 on the other side, and divide by 2. Sine theta equals 1/2. Common arc, the answer is pi over 6. As you know, sine is positive in the first as well as the second quadrant. So if it's pi over 6, the other one would be pi minus that. Okay, on 0 to pi, we get pi over 6 and 5 pi over 6. Same thing here. We are going to first move this, make it positive square root of 3 divided by 2. As far as the general solution is concerned, by the way, because they might ask you in a specific, uh, revolution, normally one revolution, okay? Or they may ask you in general. So then you have to add to each one of these 2k pi. Remember, k is an integer. So now going to this one, you take it to the other side, make it positive, divide by 2. Cosine theta is square root of 3/2. That is also a common arc with the same answer, theta being pi over 6 for the first quadrant. However, cosine is positive in the first quadrant and the fourth quadrant. The first quadrant, pi over 6. The fourth quadrant, 2 pi minus pi over 6, making it 11 pi over 6. Remember the concept of a reference arc. So this acts as a reference arc. And so again, if we want a general solution, in each case, we add 2k pi. Sometimes they say 2n pi. That means the same thing. N or k is an integer. So when they ask for find all solutions, this would be the answer. Okay, from 0 to 2 pi, this would be the answer. All solutions, this is the way you answer. Square root of 3 tan 3 theta plus 1 equal to 0. Okay, let's see how we tackle this. First, we are moving the 1. And then we are going to divide by 3. We get negative 1 over square root of 3, or negative square root of 3 over 3 if we rationalize it. This is the way you rationalize square root of 3 over square root of 3. And you get this one, okay, which is one of those common arcs. So first, look at the square root of 3 over 3. It's important to understand the reference arc. Okay, so if tan x is square root of 3 over 3 for the reference arc, theta becomes pi over 6, okay? So this would be the reference arc. But it's negative. Where is tangent negative? In the second quadrant and the fourth quadrant. So in the second quadrant, pi minus pi over 6, pi minus pi over 6, which is 5 pi over 6. In the fourth quadrant, 2 pi minus pi over 6, which is 11 pi over 6. Now, in each case, we are going to set 3 theta equals to 5 pi over 6 plus 2n pi. We do this one, everybody, now. And solve for theta. I want to tell you the methodology by which we solve this. We are solving for theta. That means we are going to divide this one by 3, this one by 3, this one by 3. Which means this becomes theta. This becomes 5 pi over 18. This is 2n pi over 3. This becomes theta 11 pi over 18, 2n pi over 3. And you look at this number, class, number 3, that means you go 0, 1, 2. If you go with 3, you repeat the same thing. So 0, 1, 2. If this is 5, you go 0, 1, 2, 3, 4, just one less than that. So just for the sake of argument, if you plug in 0, you get 5 pi over 18 here, 11 pi over 18 here. If you plug in 1, just for the sake of argument. So if you plug in 1, what happens? You get 5 pi over 18 is over, and then 2 times 1 times pi, 2 pi over 3. 2 pi over 3 is what? The denominator must be 18, so multiply the top and the bottom by 6, 12 pi over 18, 12 and 5, 17 pi over 18. Now, if we add it here, Let me use a different color. We have 11 pi over 18 plus 12 pi over 18, 23 pi over 18. And you can plug in 2 and find the answers. By the way, so we got the first 4, everybody. And the other 2, if you plug in 2, you find it. Now, because tangent and cotangent, the period is pi, okay? Because the tangent and cotangent, the period is pi. You can go with the first one, okay? This one. Let me erase my work. No, let me just actually. You can go with the first one. And let n be 0, 1, 2, 3, 4, 5, and stop. If you put 6, you see that it repeats. So even if you make a mistake of putting 6, not that big of a deal, okay? All right, this is when you have multiple angles, the methodology by which you solve an equation involving multiple angles is this method. So let me erase. So the method is to write this. The method is after you get to the answer to write this, okay? For all trigonometric functions. For tangent and cotangent, you can just go with the first one and go with this. For the rest of it, you must go with both and go 0, 1. All right. Cosine of theta minus pi over 4 equals 1. And specifically, theta is in the first complete revolution from 0 to 2 pi, reminding everybody of where you find them positive, negative, and so on. Okay. I put many different formats, whatever that makes it easier for you to remember. For example, this one, quadrant 1, all positive. Quadrant 2, sine and therefore cosecant is positive. Quadrant 3, tangent, therefore cotangent is also positive. Quadrant 4, cosine, therefore secant is positive. Or you go this route, you write it. Whatever that makes it easier to remember, more power to you. So having said that, cosine equals 1, okay? Cosine equals 1. Cosine of what angle, what arc? It's 0. So cosine of 0 equals 1. So theta minus pi over 4 must be 0, which makes theta pi over 4. And remember, from 0 to 2 pi, there's only one answer, because 2 pi is the same as 0 by the way. Now, sine of 2 theta equals 1/2. So think about 1/2. It's a common arc. The answer is pi over 6. Sine is positive also in the second quadrant, so pi minus pi over 6. Therefore, we have two answers, pi over 6 and pi over 6. This is important to remember, okay? And so what happens? What I just went over, we have to add a 2n pi. From time to time, I add 2n pi or 2k pi. Please understand, n or k, they are integers, makes no difference. And so if I want to solve for theta in each case, I have to divide by 2. So obviously they both become theta. This becomes pi over 12. This becomes 5 pi over 12. And they both become k pi. So because this is true, everybody, you can only use 0 and 1. And you can try to, it just repeats the same thing. It goes beyond one revolution. That's what happens. So obviously, if I put 0, I get pi over 12 and 5 pi over 12. If I put 1, then pi over 12 plus pi, and pi is what? 12 pi over 12. So I get 13 pi over 12. If I do it here, this is 12 pi over 12. I get 17 pi over 12. So k is 0 and 1, n minus 1, if it's sine of n theta. Just remember that in general. Those are the answers. So for sine of n theta, or the rest of them, doesn't matter. You use n minus 1 all the way to n minus 1. Now, I think you can easily see if I erase this. If I use k equals to 2 pi plus that, you see it goes beyond the 2 pi, beyond a complete revolution. That's why you don't use this number itself. Okay. All right, we want to solve the trigonometric equation, quadratic in form. The reason it's called quadratic in form because it's 2 cosine squared minus cosine theta minus 1. So this is of second degree. And everybody remembers how to factor quadratic expressions, and if need be, use the quadratic formula to solve it. So think of this as if it makes it difficult, just make this y. Actually, you can even make it x because this is theta and this is y squared. So you can factor it. Number 2 is a prime number, everybody. So all you have to do 2y and then y, because 2 is a prime number. This is negative 1. You have no choice but to use both of them. One of them negative. Okay. So in this case, 2y means 2 cosine theta, y means cosine theta. You don't have to change the variables. And so let me erase my work first, so it makes it easier to see the following. What I want you to notice is that if you multiply these two, you get cosine theta. If you multiply these two, you get negative 2 cosine theta. What matters is that the sum must be the middle term, and it is. Okay, that's how we check factoring. So having said that, we set this one equal to 0, we set this one equal to 0, and so on. This one, obviously, you move the one becomes negative divided by 2, and the other one you also move the 1. So, by the way, even if they want a general solution, first find it between 0 and 2 pi, and then generalize it. So cosine theta is negative 1/2. Please understand that the reference arc, so to make it easy for everybody to understand, when you have this one, the reference arc, if you calculate cosine of theta equals 1/2, and theta becomes pi over 3, this is a reference arc. Okay. Now, cosine theta is negative in the second and third quadrant. So in the second quadrant, okay, remember this is the reference arc, pi minus pi over 3, 2 pi over 3. In the third quadrant, pi plus pi over 3, 4 pi over 3. So those are the answers. Cosine theta equals 1 has only one answer, 0. And so here's the 3 answers. This concept of a reference arc is extremely important, and it helps out. Okay, everybody? Remember, the reference arc is the angle that the terminal sides makes with the positive or negative x-axis, the smallest angle. And so here's the next one. We want to solve this again. Um, it involves the square of sine or cosine or both. So we have to figure out what is the technique to solve. So because we have sine squared and cosine squared, and this one is sine, we're going to change this one using the fact that sine squared plus cosine squared is 1. We can say sine squared is 1 minus cosine squared, or cosine squared is 1 minus sine squared. Which one? This one we can't change, and because we want to keep it as sine, we're going to change cosine to sine, meaning cosine squared is 1 minus sine squared. That's the reason you change this one, because this one you can't change. And so we're going to bring everything to the same side. This becomes positive and adds up to this. This one becomes negative. So we have 2 sine squared minus sine theta minus 1. And I hope you see that it's practically identical to the previous page as far as factoring is concerned. This time, let's go with x. If you call this x, then what you have here is 2 x squared minus x minus 1. And again, you don't have to do that, which is 2x here and x here. And since this is negative 1, you have no choice but to go with 1 and negative 1. But where do you put them? So if you put a plus 1 here, minus 1 here, this is x, negative 2x. They do add up to minus x. And therefore, this is the way you factor. In this case, sine theta becomes negative 1/2. In this case, sine theta becomes positive 1. Again, first of all, sine theta equals 1 is equal to pi over 2. There is really not much you have to. I want to discuss that again. I want to go to 1/2 as the reference arc. So think about this as sine of, well, I'm going to call it theta sub r equals 1/2, and theta sub r is pi over 6. So always go with the positive. So that is the reference arc, negative. So you have to figure out where sine is negative. Sine is negative in the third and fourth quadrant. Therefore, in the third quadrant, you're going to say pi plus pi over 6. Pi. So in this quadrant, pi plus pi over 6. That means 7 pi over 6. In this quadrant, 2 pi minus pi over 6, 11 pi over 6. And as I mentioned, this was pi over 2. And we're done. So the reference arc is extremely important to help us figure out the rest. So you can see why they are called quadratic in form. Three sine squared equals cosine squared. So we can either change this one, say sine squared plus cosine squared is 1. We can change this one to 1 minus cosine squared and then times 3, or you can change this one to 1 minus sine squared. And I hope you see, because this has a coefficient of 3, it's easier to do the right side. Not that you have to. And so if we move this, again, the reason we did this because we don't have to multiply by 3. When we move, this becomes positive, and with 3 becomes 4 sine squared theta equals 1. So sine squared is 1/4. Take a root of both sides. Sine theta becomes plus minus square root of 1/4 or plus minus 1/2. And we have to solve two equations. Sine of theta equals 1/2 or sine of theta equals negative 1/2. Obviously, sine of theta equals negative 1/2. We already did that in the previous page, 7 power over 6 and 11 power over 6. But anyways, for this one, remember the reference arc is pi over 6. Sine is positive in the first and second quadrant. So pi over 6 in the first quadrant, pi minus pi over 6. That means 5 pi over 6 in the second quadrant. Negative 1/2. We've already discussed that same reference arc. Okay. In this case, pi plus pi over 6. In this case, 2 pi minus pi over 6. So those are the four answers. So we are solving trigonometric equations. Solve the equation 3 cosine theta plus 3 equals 2 sine squared theta. Again, from 0 to 2 pi. If they want general solution, you find the answer from 0 to 2 pi, and then you add 2n pi or 2k pi. So having said that, what do we do? Well, since this is cosine, of course, sine squared plus cosine squared is 1. We're going to change the sine squared to 1 minus cosine squared. Two times sine squared is 1 minus cosine squared. So the right side we distribute the 2, get 2 minus 2 cosine squared. And we move this one, becomes positive 2 cosine squared theta on the left. We move this one, subtract 2 from 3 to get 1. So we get 2 cosine squared plus 3 cosine theta plus 1. This is again a simple factoring because this is 2. A prime number. And this is 1. So you have no choice but to put 1 in both places, either positive or negative. And the reason you put positive because this is positive 3. But take a look. This is 1 times cosine. This is 1 times 2 cosine. They must add up to 3 cosine theta, and they do. So again, just erase this and show you what I mean by that. The product of these two and these two must add up to the middle term. That's how you did the factoring class, okay? I'm hoping everybody remembers this stuff. So cosine theta is negative 1/2 cosine theta equals negative 1. And as you recall, we did this cosine theta equals negative 1/2 already. The answers are 2 pi over 3 and 4 pi over 3. And again, I quickly remind you how we did that. So we said cosine of reference arc is positive 1/2 the reference arc is pi over 3. Now we want a negative. Cosine is negative in the second and third quadrant. In the second, pi minus pi over 3. In the third, pi plus pi over 3. So that's what we've done. Cosine is -1 when theta is pi. So we have those three answers. So those are pretty simple, everybody. I'm going to continue solving trigonometric equations. And again, we want theta to be between 0 and 2 pi, where sine squared is 3 cosine theta plus 1. Sine squared plus cosine squared equals 1. Either sine squared is 1 minus cosine squared, or cosine squared is 1 minus sine squared. And because we have cosine theta, then we're going to change the sine squared to 1 minus cosine squared. So since this is negative, we're going to make it positive on the right side because we want to put it in descending order and we want this to be positive. And so as we move it to the right, this becomes cosine squared. This becomes positive cosine squared, and 1 becomes minus 1. And we are going to factor, this is easy because this is 1 is cosine and cosine. This is 2, we want two numbers. The product is 2. And the sum is 3, so 1 and 2. So those are pretty simple, everybody. So cosine theta is either -1 or -2. Now, negative cosine theta equals -1, we know the answer is pi. Cosine theta equals -2 has no solutions because cosine theta is between -1 and 1. Cosine theta can't be -2, can't be a number less than -1 or larger than 1. In other words, sine and cosine, the same thing. So cosine is between negative and positive 1. That's so we want to make sure that we understand that. We are going to move on. All right. So now cotangent squared is 3/2 cosecant theta. There's another identity is also called the one of those Pythagorean identities where 1 plus cotangent squared is cosecant squared. We're going to use that. So if that is the case, I can move this to the other side because cosecant is there and we don't want it, we can't change that. We are changing cotangent squared. Cotangent squared is cosecant squared minus 1. So let's replace that with cosecant squared theta minus 1. Let's get rid of the fraction. Let's multiply both sides by 2 and let's bring them to the same side. First of all, if you multiply by 2, this becomes 2, this becomes minus 2, and this becomes 3, and move it this way. So one more time. This becomes 2 cosecant squared. This moves becomes minus 3 cosecant theta. This becomes negative 2. And again, it's a simple case of factoring. 2 is a prime number. So let me just write this again here somewhere. So what this means is you can put 2 cosecant theta and then 1 cosecant theta and then work on this. And this is only the product of 1 and 2. One of them must be negative. Okay, so how do you know this is the case? If you multiply these two, you get 1 cosecant theta. If you multiply these two, you get negative 4 cosecant theta, and they do add up to negative 3 cosecant theta. So that works, and it's important to do it in this manner. So cosecant is, let me erase my word, is either negative 1/2 or positive 2. And from cosecant, we're going to go to sine to figure out if there are common arcs, if we can get to the answer. Remember, cosecant is 1 over sine. Therefore, if cosecant is negative 1/2, sine is negative 2. If cosecant is 2, sine is positive 1/2. So the reciprocal. Sine theta equals 1/2. We've done it a number of times. The answers in the first and second quadrant, pi over 6 and 5 pi over 6. Sine can't be negative 2, the same reason that we mentioned for cosine. Both of them are between negative 1 and 1, and they can't be equal to negative 2 or any number beyond negative 1 and positive. All right. Example 10, solve trigonometric equations with a calculator. So we've seen how to solve the rest of them. That's something that is a common arcs, doesn't require a calculator. Now, solve and round to 2 decimals. Cosine theta equals 0.2. And of course, from 0 to 2 pi. So cosine theta equals 0.2, and we recognize this as not a common arc. So theta is cosine inverse of 0.2. And cosine inverse of 0.2, you put it into a calculator. cosine inverse of 0.2 gives you this number, 2 decimals, 1, 2. Next to number 6 is 9. We take it up and we make it 1.37. This is in radians. Now, remember, there are two answers, but when you use the inverse because of the restriction we put, it gives you only one answer. So for inverse cosine, the calculator will only give you an angle from 0 to pi. There is another angle in the interval from 0 to 2 pi with that cosine value in quadrant 4, just to make sure we understand what's going on. Cosine is positive in the first and the fourth quadrant, and we should know that. So if it's positive in those quadrants, we need to figure out what the answer is in that quadrant. And it's fairly simple, everybody. This also acts as a reference arc. Anytime this is positive, this acts as a reference arc. So if it's 1.37 in the first quadrant, in the last quadrant, in the fourth quadrant, 2 pi minus this number. So this is the first quadrant, theta equals 1.37. In the fourth quadrant, 2 pi minus that. And now, of course, you put it into a calculator, and with 2 decimals, you end up with 4.91. Radians, roughly. So that's pretty straightforward, everybody. So all went round to decimals. Tan theta is -2, and we want to go with the complete revolution simply from 0 to 2 pi and no more. It's not a common arc, so theta must be tan inverse of -2. Tan inverse of -2, you put that into a calculator. And calculator gives you that you want to go with 2 decimals, 1 and 2. 0 next to this 7 goes up. So -1.1 radians. It's important to understand that, again, we have two answers, everybody. For inverse tangent, the calculator will only give you an angle from negative pi over 2 to pi over 2. There is another angle in the interval from 0 to 2 pi with that tangent value, because negative, it's in the second quadrant. Because if you recall, tangent is positive in the first and third quadrant, negative in the second and fourth quadrant. So because we want 0 to 2 pi, positive 1.11 acts as a reference arc. If you want to bring it to 2 pi, first of all, you add 2 pi, and that gives you the fourth quadrant. Okay. If you add pi to it, it puts you in the second quadrant. Those are the values that you can get. So this is -1.1. Okay. -1.1, and this is pi minus 1.1. And then if you add it 2 pi minus 1.11. So theta equals pi minus 1.11, again with a couple of decimals, 2.03. Theta equals 2 pi minus that is 5.17 radians. One way to look at it, the period for tangent and cotangent happen to be pi. Because this is negative and we want to bring it here, add pi and then another pi. In other words, add pi come up with one answer, add another pi, or add simply 2 pi to that, come up with the second answer, because you want it to be positive from 0 to 2 pi. So 2.03, 5.17, simply add pi and 2 pi to have answers in the interval of 0 to 2 pi, anytime you're dealing with tangent or cotangent for that matter. We want to solve this 2 sine squared theta minus 3 sine theta plus 1. Theta is between 0 and 2 pi. And again, you're dealing with a quadratic in form. And so to factor this is very easy. 2 is a prime number. So you do have, let's put it up here, 2 sine theta, 1 sine theta. And because this is 1, you have no choice but to go with 1 and 1 or negative 1 and negative 1. In other words, this is positive, then the two ones that you use here, one here, they must have the same sign. Okay. So, and this is negative, so they both must be negative. So in this case, sine theta is 1/2. In this case, sine theta equals 1. We have seen this a number of times already. For sine theta being 1/2, the answer is pi over 6. In the first quadrant, pi minus pi over 6, or 5 pi over 6. In the second quadrant, sine theta is 1 when theta is pi over 2. Now, let's solve trigonometric equation using a graphing utility. Solve and round to 2 decimals. 3 cosine x plus x equals 4. In this case, this can't be solved by the old method, okay? This cannot be solved by previous method, but can be solved using a graphing utility, okay? So basically what you do, you put one side as y1, one side as y sub 2. So y sub 1 is 3 cosine x plus x, one side, doesn't matter which one. And y sub 2 equals 4. And in essence, you look for graph and then the intersection of the two graphs. So if you put it into a TI, so y1 is 3 cosine x plus x, y sub 2 is 4. Click graph and it looks like this. So this one, the left side is this function and the right side is a horizontal line. And as you can see, they have a point of intersection. So that's how you find it. The point of intersection is the answer. So use intersect to find solution. And the way you do so, in a TI calculator, if you can't find this and you can go to the default window, press the zoom button, select 6, which is Z standard, to return to the default of -10 to 10, or you can change it, okay? Also for a TI calculator, press calculator, second trace, choose intersect, which is number 5 for the first curve, hit enter. For the second curve, hit enter. For the guess arrow to the intersection, press enter. The TI-83 will return the value of x and y. Both of these coordinates are part of the solution. So you go with the calculate, you go down to intersect, and it will show you the intersection, as I mentioned, and it has the x and y. And so the x coordinate is 4.53. When you want to solve this, you're interested in finding the x coordinate, everybody, which is 4.53. So that is the calculator. Y, the first one, you put 3 cosine x, close parentheses, plus x, you enter, and the next one you clear it and you put 4, and you graph it. 3 cosine x plus x. I think I then put the x. Let's see. Enter. Okay. Enter. Let's graph it now. So it shows you the graph. We don't see the entire thing. We click on zoom. Standard form brings us to the graph that we had. Again, trace. We bring it down to intersection. Enter, enter, and then bring it down closer to the intersection, and it gives you the answer that we had here. X equals 4.533578, and we are going with 2 decimals. That's how you use it. Graphing calculator on that if need be.